simulation. اللي أنا أعرفه عن الموديلنج إن هو مثلا لو أنا عايزة عندي فكرة في دماغي وعايزة أطبقها في الريل لايف، فبالتالي أنا هعمل لها بروتوتايب. مثلا نفترض إن أنا عايزة أعمل كرسي. الكرسي ده أكيد ليه دايمنشن معينة وأكيد ليه requirements معينة تانية، مثلا خاصة إذا كان الكرسي ده معمول لناس فئة معينة أو إذا كان ناس مثلا عندهم إعاقة، فبالتالي أكيد في requirements معينة المفروض تتوافق في الديزاين بتاع الكرسي بتاعي. فخلاص دلوقتي أنا حولت الدروينج اللي عندي وكل حاجة عندي اللي هو بروتوتايب، فبالتالي أنا كده عملت موديلنج الديزاين بتاعي.
modeling and simulation اللي انا اعرفه عنها ان هو بيكون mainly الانجينيرز لما بيكونوا عايزين يعملوا تيست ران او عايزين يجربوا برودكت جديد او عايزين يعملوا حاجة فيها ديجيتال موديل، بيعملوها الاول طبعا بروجرام على كمبيوتر وبتاع، وبعدين بتبقى ليها تيست ران بس من خلال الكمبيوتر قبل ما تعمل هاردوير، او من خلال الموديلنج ان هي ممكن تبقى موديل باي حاجه اصغر بحيث ان هي تبين هل الستراكشر ده ينفع اصلا ولا لا.
What is modeling? Modeling is a process of producing a model. What is a model? Model is a representation of the construction and working of some system of interest. For example, if we have a system, we can make an experiment with this actual system or make an experiment with a model. If we use the model, we can use physical model or mathematical model. In case we used mathematical model, we can perform simulation or analytical solution. And regarding simulation, there are three types of simulation: static versus dynamic, deterministic versus stochastic, and continuous versus discrete. So what is simulation? Simulation is the imitation of the operation of a real-world system over time, which means that we choose a certain system and operate it virtually on a model. Simulation involves the generation of an artificial history of the system and the drawing of inferences from it. And why is that? Because we need to collect the exact data and history of the real-world system in order to achieve what we call accurate simulation. The steps involved in developing a simulation model, designing a simulation experiment, and performing simulation analysis are 12 steps. The first one is identify the problem. We have to identify a problem, as this is the main cause of performing simulation analysis. Step 2. Formulate the problem, as we have to transform the real-life system problem into a formula that we can analyze and perform simulation on its model. Step 3. Collect and process real system data. As we mentioned before, we have to collect correct data and history from the real-life system to be able to process the exact simulation. Step 4. Formulate and develop a model that we can use to perform the simulation and reach the analysis. Step 5. Validate the model, which means that we have to make sure that the model is valid and suitable for correct analysis. Then we go to step 6, which is document model for future use. Documentation is important and it permits the model to be really usable in the future and ready for modification. Step 7. Select appropriate experimental design. Step 8. Establish experimental conditions for runs. Both selecting design and establishing suitable conditions are essential for the trials and experiments to be performed. Then step 9. Perform simulation runs. Step 10. Interpret and present results, which is our main aim. Interpretation is observation and understanding of the experiment, so we can reach the conclusion and the results that we should present. Step 11. Recommend further course of action. After presentation of results, we document it and make reports with recommendations to guide those who will use the model in the future. And finally, step 12. Implementation, in which we apply the results on the real-life system solve the problem. This is a flowchart that illustrates the steps practically. We start with the problem formulation, in which we identify the objectives and project plan. Then we start model conceptualization and data collection. That leads us to model translations. After that, it has to be verified. If not, we get back to model translations. And if yes, it's verified, we see if it's validated. If it's not validated, the problem has to be in the model conceptualization or data collection. And if yes, it's valid, we start the experimental design. Then we start the production runs and analysis. We produce more runs. If interpretation is not possible, we examine the experimental design, and then start all over again the production runs and analysis. If interpretation was possible and the runs succeeded, it leads us to documentation and reporting that follow the results presentation, and then implementation. Simulation tools. There are three choices exist. Build the model using a general computer language, for example C++. Build the model using a general simulation language, for example SimScript. And 3. Build the model using a software package, for example Arena. Regarding the general computer languages, there are advantages and disadvantages. Its advantages are little or no additional software cost. It's universally available, which means it's portable. No additional training, everybody knows the language. However, every model starts from scratch. You have to start from the very beginning. Also, it's very little reusable code, and long development cycle for each model. As for the general simulation languages, its advantages are standardized features often needed in modeling, shorter development cycle for each model, much assistance in model verification, very readable code. However, its disadvantages are higher software costs upfront, additional training required, and limited portability. In the simulation software packages, its advantages are very quick development of complex model, short learning cycle, no programming, minimal errors in usage. On the other hand, its high cost of software, limited scope of applicability, and limited flexibility may not fit your specific application. So, who is the only person who is capable of working on modeling and simulation software? An industrial engineer is the only person. Thank you for listening.